Hi, I'm Assad.
Rohit. I'm Drew. And today we're going to be demoing our project, which is a RF motion controlled robot. It has two major components, our RF communication as well as the accelerometer, and Drew's going to talk more about the accelerometer.
So the way that we control our robot is we wanted it to be kind of like a steering wheel. So you turn to the left and the right, and you can control it that way. And if you tilt it forward, you can also make it go forward, and if you tilt it back, it'll go back.
Gotcha.
And all that is done basically just by using thresholds in the accelerometer. And then we also use two thresholds for the accelerometer. So if you tilt it a little bit to the left, it'll go slowly to the left, and if you tilt it even more to the left, the speed ramps up a little bit on the servos.
All right.
Same thing for forward, back, and right. And then the accelerometer communicates with the PIC using I2C. And then on this side, we are able to decode the accelerometer's readings and basically make a code that is a full byte that we can transmit through RF to the robot.
Okay, so the communication is by 433 megahertz control channel.
Yep.
And you have to roll your own protocol when you use 433 because it's raw RF. There's no protocol. Or you get to invent the protocol, which is a blessing and a curse.
Yeah. Essentially, the protocol that we ended up using is that we start with transmitting two characters of AA and then FF. And the reason for that is the receiver will actually adjust its gain based on the characters that are coming in, so that kind of readies the receiver for our payload. And then after that, we also transmit two start characters. So we initially started with just one start character of FA, and we specifically chose FA because it was a signal that would be more discernible, as well as using. We ended up using two so that it's a much more reliable start case that we're going to be transmitting.
So you get very few false positives that way because
Exactly.
there's a lot of redundancy.
Yeah, it defines
Good.
like a valid payload, basically.
Good. Okay, and then you have the payload byte after that.
So as Drew said, so for those to adjust the gain, then having that very discernible byte after that. As Drew said, we do have the one byte that corresponds to a given direction. So based off the threshold readings from the accelerometer, that one byte will correspond to either forward or fast forward or back fast, and then left and right. It's the same idea.
So that's a total of 8 bits, right?
Yeah.
Okay. Okay. Well, fire it off. Let's watch it go.
Okay. So also I forgot to mention as well, we have a button here.
Yeah.
So it only transmit a straight or any character if we're pressing the button.
So this is kind of like the kill switch or the ignition switch kind of
yeah,
thing.
it's
Okay.
almost it's more like an ignition. So then I'm tilting it forward a little bit, so it's going slowly. I tilt it forward a little more, it goes a little faster.
Okay.
I have to follow it. RF.
Now go put it in reverse.
So if I go in reverse,
Okay.
back, go left, go left.
Because you have to tilt it both ways at once, right, to do that.
Yeah. Yeah, we're good. So it's kind of tough with our signal strength, but it eventually goes.
Yeah. Okay. And how often are you sending the code?
So right now, I believe we're sending it every 150 milliseconds.
So if it misses the first time, it'll get it the second time.
Yeah.
And you can, so you have some redundancy in repetition rate also.
Yeah, exactly. That way, because it's inevitable to miss, and then that way it makes it more reliable if it goes farther away.
Okay, back it towards you a little bit more. Okay, so now forward again a little bit. And now turn it one more time. Very cool. Okay. Looking good.
Thanks.
Okay, thank you.